Okay, guys, last video for 1.1. In this section, I guess this part of 1.1, what we want to do here is we want to get used to solving for a single variable, say in this case for W, when we have other variables involved. And it really is the same process. People sometimes just get a little nervous when this happens, okay? It works the same way as it does as if you just had one variable with a bunch of numbers. So for example, solve each formula for the indicated variable and fully simplify. This first one I marked as easy because it'd probably be, and this would be a good example of an easy question on the first test, okay? The one below is more of a moderate, typical sort of question, okay? So I'm looking for W, so I'm still gonna follow the same rules. I gotta get rid of 2L. Well, I think it makes sense to subtract 2L from both sides. By the way, this is the equation for the perimeter of a rectangle, in case you were wondering. So the perimeter minus 2 times the length is equal to 2 times the width. From here, it's not too hard. How do I get W by itself? Well, divide it by 2. So if I divide both sides by 2, I'm getting the width is equal to perimeter minus 2 times the length divided by 2. And there's my width, okay? So not too bad. Now, you might see it in a different form. If you were to look this up in the back of the book, it might say something like this. P over 2 minus L, okay? Do you understand why these two things are the same? You can split the numerator. P over 2 minus 2L over 2, or just L. I want you to make sure that seeing that this and this are the same, that should be very easy for you, okay? If it's not, that's all right, but send me an email, put something on the discussion, you know, get with me or someone else and make sure you understand that these two things are the same thing, okay? So that's a good warm-up for this one. This one's a little more fun. Negative x equals 5x plus 3 times 3k plus 1, and we're going to solve for x. Okay, so we're looking at this. There's not just a single x, there's a bunch of x's. Well, I guess there's technically two. So how am I going to do this? Well, I know since this is linear, it will be linear, I want to get the x's together. So I think the first thing I should do is I should unpackage this right-hand side. How do I unpackage this? How do I get this kind of expanded out? Well, we can FOIL it, right? If you remember from your algebra. So that's what I'll do first. Negative x equals, this is going to be 15xk, okay? And keep in mind, we're just trying to get, we're going to end up trying to get all the x's together. So that's from the first. The outer, 5x times 1, is positive 5x. So once again, there's another x we have. The inner for the FOIL is 9k. And the last is 3. So I've unpackaged that right-hand side. I see that I got 3 x's in here, and I'm like, okay, I got to get all these x's together somehow. Well, one way is I can add this x to both sides. Okay, now I like to keep things lined up with like terms. I can't add it to this because this is an xk. However, I can add it to this because this is just an x. So I can do it like so. Notice how I just lined it up with the term that it's like. Okay, so over here I got 0 now. This is equal to 15xk plus 6x, right? 5x plus x is 6x, plus 9k plus 3. And I'm seeing, okay, well, at least now I have it condensed back down to 2 x's. But I need them to be a single x. But I can't really add these because this is not just 15x, it's 15xk. What could I do? Okay, that's what we want to think about. Well, before we do anything, let's get the stuff without the x's, the 9k plus 3. Let's just move that over to the other side. So to do that, I'll subtract 9k and I'll subtract 3, and I'll do it from both sides, right? Because that's the whole rule. So I have negative 9k minus 3 equals, now, right here, so these are going to cancel, and I just have this left. If they both have an x, what is that thing from algebra we can do when they have things in common? Well, we can factor it out, like so. Okay, so hopefully that wasn't too big of a step. Okay, I factored out the x. And now the x, I sort of kind of got it on its own, but I still have it being multiplied by this. How do I get it by itself? I'll divide both sides by that 15K plus 6. Then I'll be able to have my X alone, just like I want. Okay, so we're right here. Let's go over this way because I'm running a little low on room. So now I have negative 9K minus 3 over 15K plus 6 is equal to X. So that's my answer. Or is it? If this was your final answer on the test, you'd get some points, but you wouldn't get all your points. The reason being is we want to fully simplify. Well, what is there left to simplify? Well, I'll show you what there's left to simplify, okay? What we want to do here is look. Notice on the top that I can do a little bit of factoring here. I can say X equals, I can pull out a negative 3. Then what I'm going to end up with is going to be a 3K, right? 3K times negative 3 is negative 9K. I'm not changing anything. Plus 1. Down low, 15K plus 6. I can pull a 3 out of that. 3 is a common factor to 15 and 6. And then I'm going to have 5K plus 2. Now that I've done that, now I can go ahead and I can say, oh, I got a 3 here, I got a 3 here. So those are both reduced to 1s, or I mean, you can say they cancel, if that's the way you like to say it. And really, X is equal to negative 3K plus 1 over 5K plus 2. Or you might see it written like this. Negative 3K minus 1 over 5K plus 2, where they distributed the negative. Or it could even be written like this. The negative out front, 3K plus 1 over 5K plus 2. So there's a lot of different ways you could write that final answer. As long as it's fully simplified, I don't care in which form you have it, as long as it's fully simplified. Okay? So there's our final answer. We're good to go. One more type of problem I want to do, and that's going to be this one. Example, convert 104 degrees Fahrenheit to Celsius using this formula. Maybe you've seen this before. Okay, this is to convert from Celsius to Fahrenheit, which is the opposite of what we want. That'd be easy. We just plug it in and we get an answer. But we want the Celsius, so what are we supposed to do with that? Well, this is a direct application of what we just did. We want to solve for Celsius, okay? Sure, you could plug it in first, but then it's kind of cumbersome with all the numbers. So this is one of many examples we want to be able to do, like what we did with those two last problems, is sometimes we don't want what the formula is written for. Sometimes we want the other one, so we got to rearrange it. And, you know, this makes sense because everywhere else in the world, well, not everywhere, but in a lot of places, they use Celsius. We use Fahrenheit, so it might be useful to convert these, okay? So what I'm going to do is I'm going to try to solve for the C here. I'll start with subtracting 32 from both sides, okay? I'm way off to the side, so I guess I should get a little more centered. So Fahrenheit minus 32 equals 9/5 times Celsius. Okay, 9/5 times C. How do I get rid of that 9/5? I hope you remember from your algebra. What I'm going to do is I'm going to multiply both sides by the reciprocal of 9/5. Does that sound familiar? I hope it does. And it's very important to realize this 5/9, it's happening to the whole side. Don't just do it to the F. Okay? And you can see if I multiply, this would be 45 over 45. That's just 1. That's C, just like we want. So the formula for Celsius is 5/9 times the Fahrenheit degrees minus 32. That's what we get for Celsius. Now that I've reworked this formula for what I want, now I'll plug in the 104 for Fahrenheit. Okay? Now, like I said, I think that's the easier way. If you want to plug it in earlier, you can. This is the way I like to do it. So let's see what we get. 5 over 9 times 104 minus 32 is equal to C. Okay? From right there, that's 5 over 9 times, this is 72, is equal to how many degrees we have in Celsius. Now, it's very important, and I think you guys realize this, but if you don't, Realize that this, of course, is the same as 5 times 72 over 9 equals C. And then I can say, okay, 9 goes into 72 8 times, so that we get 40 degrees Celsius is what 104 degrees Fahrenheit is. Okay. This wraps up section 1.1. Thank you.